I'd like to take a moment to review what we covered in this past module. I hope it helps give you a broad overview of what's going on, but if you still have any doubts about the specifics, I encourage you to rewatch those videos or post some questions in the discussion forum. We first heard from Alex about the differences between artificial intelligence, machine learning, and deep learning. We also learned a little bit about the history of machine learning and what it can be used for. Then, Alex and I discussed the importance of keeping ethics in mind when working with machine learning since, like any tool, it can be used for good or evil. Ensuring your data is balanced and does not contain any inherent biases can go a long way toward creating a fair model. We learned about the differences between single-board computers and microcontrollers and how machine learning can be effectively used on each, as well as their limitations. Next, we had a guest lecture from Tumas about how advances in microcontroller and microprocessor hardware has made running machine learning algorithms more efficient. Then, we heard from Felix about how various software frameworks can work together to optimize machine learning algorithms on a microcontroller. I showed you how to create an Edge Impulse account and how to begin collecting data with your smartphone or Arduino board. I talked about how to divide up your data into training, validation, and test sets, and why those sets were needed. I then gave you an example about how training a model with biased data can produce a biased model. This is important as it relates to ethics as well as creating a model that meets your needs. After that, we dove into feature extraction, why it's needed, and how to do it for our motion detection example. Machine learning models can sometimes learn features on their own, but often we need to help them by pre-calculating things like the root mean square or the fast Fourier transform of the data. Finally, we talked about what a machine learning training pipeline looks like and how that differs from a pipeline to perform inference. Training is often much more complicated and requires a lot of tweaking of hyperparameters to get the model to do what we want. In my experience, I found that it's often best to get something up and running as quickly as possible before starting to tweak the model and hyperparameters. This can help you determine if you're even on the right path before spending months researching some obscure machine learning algorithm. Inference is a little different in that it just requires collecting data, immediately transforming that data into features, and then performing a forward pass in our model. The output of the model is a prediction, and in the case of classification, it's a prediction as to which class the model thinks the data belongs to. We'll get more into training and inference in the next module, and we'll actually deploy the machine learning model to our embedded system.